We are doing carbon and its compounds, and today we will be discussing how to name any hydrocarbon or any carbon compound or any organic compound. Now, any hydrocarbon or organic compound is normally given two names, common name and IUPAC name. Common name. Common name is given for very simple hydrocarbon. For the complex one, we do not give common name. And for IUPAC name, these are the standard name which are given according to some set rules which are given by International Union of Pure and Applied Chemistry. It is a structure or a body which decide the rule how to name any organic compound. So these names are followed worldwide and they have set rules and standard which we have to follow to give any name to any hydrocarbon. So let us first start how to do IUPAC nomenclature, that is how to name the compound according to the set rule or the standard system. Now, to understand this, at your stage, we are doing or we are understanding, we will be understanding the naming with the help of alkanes. You know, alkanes are saturated hydrocarbon which have only carbon-carbon double or triple bond. Later on, we will apply in other cases also. So, in case of alkane, if you see the name alkane, it has got two part. The first part that is your alk part, this is called as the base part. The first part is the base part, and it shows the base part shows the number of carbon atom. Okay, so in any compound, if we have two carbon, then we have to give name according to the rule in the beginning, and we will write it in the beginning of the name. Now, later part of the name has been it will show you what type of bond we are having or what type of compound we are having. Like for example, in our case, we are doing saturated hydrocarbon, that is alkane. So the second part of the name will be representing the nature of compound or the type of compound. In our case, it is saturated hydrocarbon, which is alkane. Okay, now this alk part or the base part is given a particular term depending upon number of carbon atom. Like for example, for one carbon compound, alk will be meth. For 2, alk will be eth. For 3, it is prop. For 4, it is but. 5, pent, hex, hept, oct, nom, and dec. So you have to remember that if you have, for example, 6 carbon compound, in that case, what should be the name? Name should start with hex. Okay, and since we are naming alkanes, so it will be hexane. Okay, like for 6 carbon compound with single bond only, it will be hexane. So this is how name of any hydrocarbon is given. Now, in few cases, when we have branches, we have seen already that sometimes branches are present in any compound. So, in case of branches, branch we have to give a name. Okay, a branch is called as a substituent or it is called as alkyl group or it will be what? A side group or a branch, and this is obtained, that is alkyl group or a substituent or a branch will be obtained by removing one hydrogen from any alkane. Now you know it very well that in alkanes every carbon form 4 bond, and if we remove one hydrogen, one valency will be free. When we remove one hydrogen, one valency will be free. So we are left with a carbon where one of the valency is not satisfied. For example, in case of methane, we have CH4 molecule. So from methane, if we remove one hydrogen, we will obtain this group, CH3 group, where this line or dash is depicting that one bond is free. It can attach itself with the help of this bond. This group is called as methyl group. The same concept we can apply. For example, like let us have in the table. For 2 carbon compound, we write it. So it is, for example, we have this compound C2H6. Here 2 carbon atoms are there and all bonds are single in this compound. It is called as ethane. Okay, now from ethane, if we remove one hydrogen, so what we are left with? We are left with C2H5 and one valency on one of the carbon will be free. This is called as ethyl group. So ethyl group is a substituent. Yes, it will be a substituent and or it will be a branch. Fine. Same is for any number of carbon atom. Now there are certain rule according to the IUPAC system, and what are these rule? The very first rule, whatever compound is given to you, what you do, you write down the structure of the compound, okay? And after writing the structure, you will identify longest chain or parent chain or longest chain. This longest chain should be a continuous chain, like for example a wire. It will not be breaking at any point. We should have a continuous chain of carbon atom. So we will identify that longest chain, or on the basis of longest chain we will give this which we call as parent chain. We give the parent name to the compound. Okay, how parent name is given? This is how the parent name is given. Okay, so sorry, on the basis of after identifying longest chain, which is the parent chain, we give what? Parent name to the compound. Next, we have to identify all substituent. If any branch is there or any group is attached, then we have to find out that what is that group or branch on the parent chain. Then after this third step, we have to number the parent chain from one end. If branches are there, then we have to number the chain. Okay, and we have to number the chain in such a manner that the groups which are attached, they are getting the lowest position, or if more than one groups are there, then we will get lowest sum of the position. This idea we will discuss when we will be doing the example. Fourth one, if same group come more than once, like for example 2 methyl groups are there. If methyl groups are, there are 2 methyl groups, so for 2 we use di. If 3, then we use tri. Okay, and then finally name is given like this. First we will give the parent name. Okay, before parent name we will write down the name of the group, and then we will give the position of the group. So first is the very first idea, as we did here, the first we will write down the parent name, and before parent name we will write down the name of the group, and we will write down the position of the group. Okay, while writing the name, one thing you have to keep in mind, what is that? If we have any two alphabets, so alphabets are not separated, they are written continuously, but a number is separated. For example, 2 is there and we are writing methyl, so number is separated. 2 is number and methyl is starting with an alphabet, so number is separated from the alphabet with a dash. Okay, and any two number, for example 2 numbers are separated by comma. So we have to be very careful while writing the name with the help of this idea. Now sometimes we have a cyclic ring, so for cyclic compound no change is required. What we have to do, simply we have to add prefix cyclo before the parent name. Okay, so these are the rules. These will be more clear when we will be doing the example. Now have a look here in our case. The very first rule, we have to write down the structure. From molecular formula, we cannot give name of any compound. We will open up the chain and we will write down the open structure of the compound. Now in our structure, have a look here. This is the straight chain. Yeah, and this chain is having how many carbon atom? 3 carbon atom. So parent name is given on the basis of how many carbon? 3 carbon. Fine. Next, there is a branch. This is the branch. One branch is present, and now what we do, we will write down the name of this branch. What is how we identify this? 1 carbon, so it is called as methyl. It is CH3 group. Okay, methyl, and the chain is having 3 carbon atom. When we have 3 carbon atom, it means the parent name should have base part as prop. And all single bond, therefore we write plus N because all single bond. So the name of compound here will be name of group and parent name. In this case, we will not write down the position. Why? Because there is only middle carbon where we can have this carbon. There is only middle carbon where we can have branch. If branch is here, it will become straight chain, or branch is here, it will become, this carbon is here, then it will become straight chain. Okay, so only possibility is the middle carbon. Therefore, no need to write down the position of the group. How name is given? Name is given as your IUPAC name is your methyl propane. Now name is written as parent name is written as a continuous name. No break is there between the alphabets. Okay. If you are writing it as carbon 2 is having group. Okay. So you can write it as 2-methyl propane, but that will also be okay. This is also okay. Now next compound. In this compound, we are having 4 carbon which are arranged in a chain. So 4 carbon, okay, 4 carbon, that means what? Prop. And all single bond, that means N. Sorry, N. So name of this compound, IUPAC name is, this is propane. Fine. Next, in this case, again, the 5 carbon are arranged in the straight continuous chain. So this compound is named as pentane. Okay. In the next one, we have a straight chain of 4 carbon atom. Fine. So 4 carbon atoms are there. For 4 carbon, what we write? For 4 carbon, we write but. Yeah. And all single bond, therefore it will be N. But we have one methyl group attached here. This is the alkyl group here. And we have to number the chain here. Although again here is only one possibility, but I'll show how to number. So from left hand side we will number. Will not number from right hand side. Have a look here. 1, 2, 3, 4. This is first carbon, second carbon, third carbon, fourth carbon. Okay. Or if you are getting confused, we can write it this way also. Like this is carbon number 1, this is carbon number 2, this is carbon number 3, and this is carbon number 4. So in this case, your group is getting on second carbon. Fine. So we will write it as, position is written first. So it is 2, then methyl. So between number and alphabet, we will put a dash. So it is 2-methyl and compound is butane. Rest of the name will be continuous. We can number the chain from right hand side also. If we would have numbered from right hand side, then have a look what is the difference. If we have numbered from the right hand side, then in that case, this is 1, 2, this is third, and this is fourth. Your branch is getting on third carbon, and what we have said in the rule, number the parent chain from one end such that substituent get lowest position. Okay, so lowest value. Therefore, we will number the chain from the left hand side, not from the right hand side. Now next compound. In the next compound, we are having a straight chain of 3 carbon atom, and there are 2 groups attached. One methyl group here, another methyl group is here, and both are on the second carbon. So what we have, the name of this compound, 2 methyls are there. Therefore, for this methyl and for this methyl, we will write dimethyl. Okay, and for the parent name, here we are having 3 carbon atom. Therefore, we will write here for 3 carbon, we write for the parent name prop plus N. Here but plus N because all single bond. So compound here is what? It is dimethyl propane. Okay, we are not writing here number. Why? Because there is only one possibility. Either we are numbering from right or left. We are getting middle carbon where we will be having the branch. So it is dimethyl propane. Now next compound. In this compound we have a straight chain of 1, 2, 3, 4, 5 carbon atom. Fine. And we are having branches. One methyl here, another methyl here. Okay, so we will straight chain is having how many carbon? 1, 2, 3, 4, 5. So for this we will write pent plus ane. Fine, as a parent name. Now branches are 2, so we'll write dimethyl. Now we will number the chain. See, I am numbering from left hand side. So first carbon, second carbon, third carbon, fourth carbon, and fifth carbon. Fine. So your branch is on second carbon and third carbon, and 2 plus 3 will be 5. Suppose I am doing it from right hand side. So it is first, second, third, fourth, fifth. So first branch is coming on third carbon and second branch is coming on fourth carbon. So 3 plus 4 will be what? 7. Which one is the lowest sum? This one is the lowest sum. So therefore we will number the chain from left hand side. We will not number in this manner. And this is given in our one of the rule. Okay, what? Number the chain from one end such that substituent get lowest position if one substituent, or substituents get lowest sum of the position. So we will find out the lowest sum of the position. Therefore, what we have, we are having on second carbon methyl and on the third carbon methyl. So we will position first we will write. First methyl on second carbon, comma, third methyl on second carbon. And here numbers are separated by comma. Then we have to write alphabet. So therefore we will put a dash and we will write dimethyl. And parent compound is pentane because 5 carbon atom. Okay. Now come to the next one. In this case, your main chain is this one. Okay. Is it right? Main chain is this one or not? Find out the longest chain. Well, just a minute. You will have confusion. We will add one more carbon so that it will be more clear to you. So, for example, we are having one more carbon. Hydrogen, hydrogen, hydrogen. We are having this. Okay, fine. So, the longest chain in this case is this carbon chain. And how many carbon atoms are there in this case? 1, 2, 3, 4, 5 carbon atom. Okay. Again, parent name is pentane. Now there are branches. First branch is your ethyl. There are 2 carbon atom. This is C2H5 ethyl group. And the second branch is methyl CH3. Now we will number the chain. Apply the same rule. We will get the lowest sum. Therefore, we'll number from the left hand side. 1, 2, 3, 4, 5. So on second position we are getting methyl and on third position we are getting ethyl. This is methyl and this is ethyl as a substituent, and main chain is having 5 carbons. So we'll write pent again here. Okay. Now what we have, compare your first alphabet of both the groups. Methyl start with M and ethyl start with E. So alphabetically E will come first and then M. So when we write down the name, we will write name of different group in alphabetical order. Therefore, ethyl will be written first. Now ethyl is attached on which carbon? Third carbon. So therefore it will be 3-ethyl. Then we write 2-methyl. Just have a look here. Every number in alphabet is separated by dash. and parent compound is pentane, so pentane. This is all about how to name different hydrocarbon or alkane. Now these compounds, as we discussed, they are given some common names also. In case of common name, we will not find out any longest chain or straight chain. What we do? We find out total number of carbon atom, and on the basis of total number of carbon atom, we will give parent name. Then we will add prefix N or iso or neo depending upon what type of branching is there. Okay, suppose here have a look. Suppose we are having a continuous straight chain of carbon atom. Sorry. If we are having a straight chain of carbon atom like this, then this is an arrangement. If we have a straight chain and a branch at one branch at one point, this is iso arrangement. And if we have such arrangement at the same point, we are having two branches, this is neo arrangement. We will apply this in the examples we have done for different isomers or the structures. So have a look here in this case, third, fourth and fifth structure. Okay, in your third structure, all carbon atoms are arranged in a straight line. And how many carbon? 1, 2, 3, 4, 5. So on the basis of all carbon atom, common name given to this compound is N-pentane, because all carbon atoms are arranged in the same straight chain. Now in this case, we have second example, 4 carbon are in a straight chain and 1 is in the branch at one point. Total 4 plus 1, 5. So this one is named as isopentane. And the third one, in the third one, this is the chain, and at the same point there are two branches. That is, second carbon is having two branches. Yes. So therefore this is neo arrangement, and this compound is called as neopentane. So have a look here. In common naming, we will look into total number of carbon atom. Therefore all are pentane. They are isomers of pentane. But IUPAC name is different because it depends upon total number of carbon atom in the what you call straight chain, and therefore it will be having different name. So for example, I am giving you one example, so you let me know. For example, this is the compound CCC, and we are having carbon here, one more carbon here, and this is the arrangement. And at all ends, what we are having here, hydrogen atoms. So suppose I am representing hydrogen atom with a dot. These are hydrogen atoms. Fine. So can you name this compound? So in this case, total number of carbon atoms are how many? 4 in here. 1, 2, 3, 4, and this is 5, and this is 6. So 6 carbon atom. So this is, and the branches are such that on the same carbon there are branches. Therefore this compound is named as neohexane. Okay, why neo? Because two branches at the same point. This is the main chain, and this point is having branch, and this point, the same point is having branch. So this is neohexane. Now till now, whatever structures I have shown you, they are the structural formulas. Okay, we will open up the chain. All carbon atoms will show, all hydrogen atoms we will show, and the same compound, the one which we have written here, neohexane, it can be given by the molecular formula also. Yeah, but in addition to molecular formula and structural formula, we have one more which we call as condensed structural formula. So what is the difference between the three? For example, we are writing this compound C3H8. There are 3 carbon atoms and 8 hydrogen atom, and this compound here, this is what, this is first one, that is your molecular formula of the compound. Now if I open up like this, I will open up carbon atom and then I will open up all hydrogen atoms. So 1, 2, 3, 4, 5, 6, 7, 8 hydrogens I have shown here. So this is what, this is the structural formula, that is the second one. Okay, now the same one we can represent in one more way, and what is that way? I'll show you here. We can write structure formula in this form, like CH3, CH2, CH3. In this condensed structural formula, this is your condensed structural formula. In this formula, we are showing how carbons are arranged. Carbons are arranged in the form of straight chain, as in this case, carbons are arranged in the form of straight chain. But this formula is not showing all the bonds. Only carbon-carbon bonds are shown. So this is your condensed structural formula. Okay. So any hydrocarbon can be depicted by any one of these. If you have to name the compound, then always correct naming is done when you represent the compound in the form of its structural formula. Okay.